Hey people, how are you? Um, Sorry that I have been off. I was a bit unwell. I don't know what happened. Maybe something I ate upset my stomach a bit. So I just decided to just chill out a bit. So now I'm gonna do the P1. Yeah, hi everyone. I will do some, I will answer some key one questions. Okay. By the way, I'm just going to explain quickly that the people that will majorly benefit greatly from my videos, as I've said from beginning, are people who are struggling. All right, they're struggling to remember, you know, some of the things they did in year nine. So I go through the basics because you got this exam in 2 days. So the basics, the little bits and pieces here and there that you can remember, they're the ones that you need to take with you to the exam. So I've got a series of questions here, about 15 of them, between 15 and 20. The reason it's between 15 and 20, oh, it says my battery is low. I need to plug it in, if you excuse me for a minute. All right, I'm gonna just plug my battery, my charger into the computer so it doesn't go off. There you go. All right, so what I'm gonna do, I'm gonna just go through those questions. So I've got a series of between 15 and 20 questions because some of them overlap. You say my connection is unstable. I'm gonna just try and change connection and I'll do it again. So I'll switch my internet connection, or is it okay? Can everybody hear me clearly now? So I've got a few questions to go through. So without wasting much time, and by the way, I'll upload these questions as well. It says, how is energy stored in different forms? Okay, forms of energy, remember, you have kinetic energy. You have kinetic energy. That's energy that things have because they are moving, they're in motion. In motion, you have gravitational potential. You have gravitational potential, and then you have gravitational potential because things are high up, because they are at a high exalted place. That means they are high above the ground, up at a particular height. Like if water's falling down from a waterfall, that will have gravitational potential energy. And you know, a roller coaster, when it's at its highest peak, it has a gravitational potential, right? And then you have stored energy as elastic potential as well. You have elastic potential energy. Some people will say strain, of things that can stretch, like your bow, or like in a rubber band or in a spring. Those are your examples. Then another one students don't easily remember is chemical energy. Now that's the energy in batteries, yeah, in food, and in fuels in our bodies, all right, as well as bodies of plant. And then another one you need to remember is thermal energy or heat energy. Yeah, those are examples of forms of energy. All right. This is combined. This is combined. It's not triple. It is combined. People that are doing triple, as far as I'm concerned, they're usually okay. So I just support people who are doing combined, who are really saying, "Oh, I might get one or two." We want to be able to raise their level so they can get like up to a five. They can easily get a five because I'll go through a lot of questions. These are energy stores. Yes, they are energy stores. And then he said we should state two ways or two places where these energies are transferred. Yeah, I was going to add light. Sometimes they will say light waves, or, and then you have sound. Sometimes they will say sound waves as well. And then I think those are the energy stores. Those are the from different forms of energy. All right. And another very key thing you need to remember is how to use Sankey diagrams to represent them. These are very easy things for you to remember in the exam. That's why I'm going through these ones. All right. It says state two places where energy is wasted and where it goes to. All right. The one I can think of is in a light bulb, for example. When you have your light bulb, right, you want the energy from either battery. If it's connected to a battery, that will be chemical energy. So it's coming from the chemical energy and is transferred to light. All right, that will be your useful energy. But again, some of it is transferred into heat or thermal. Now, you don't need the heat and the thermal. You don't want your light bulb to be hot. You don't want your light bulb to be hot, okay? So therefore, that is the waste. And you can draw, you can so if your light bulb is connected to socket, then it would be from electrical to all of these forms, okay? Now you can use the Sankey diagrams to show these sort of changes. Say for instance, you have energy input at 140 joules, for instance, and then in your light bulb, it goes to say about, I want to make it so much bigger. So useful energy is that this will be the waste. This will be the waste, which is the heat, which you don't want. And if they say to you that the useful one is, say, 100 joules, and what is that? It's very simple. It's 140 take away 100, which is 40 joules. And if you want to calculate efficiency, is that one which is useful. So 100 joules divided by the initial one, yeah, times 100%, you will be able to calculate the efficiency. Okay, I will go over the formulas of kinetic and gravitational. Yes, and a way to remember it. Okay, I'll try. And then it says, yeah, kinetic energy. That's where we are now. That's question 6 on my formula. So on my my series of questions. So kinetic energy is the energy of moving objects, and the amount of kinetic energy an object has depends on the mass and the speed. So you need to remember what they depend on, because you can be asked that as well. It depends on the mass and the speed, which means if something is moving faster, definitely you have a higher kinetic energy. So the formula for that, this equation is for higher tier, by the way, is not for those that are doing the foundation tier. So it's half of x times half times mass, all right, times speed raised to power 2. That is the formula. So it says how much kinetic energy does a person of mass 50 kg have at 3 meters 3 meters per second. So raised to power 2, which means is that times 9. Remember, there is the half there as well. So when you finish, it's going to be 225 joules. All right. Now for calculations relating to joules and seconds and all of that, if you are given thank you very much. If you're given any calculation in kilojoules, right? Remember, you need to convert it to joules, especially if the time or if the speed is given to you in seconds. So you must convert it. If the time has been given to you in minutes or hours and you have kilojoules, well, you might not convert it. But the good thing is, if you're writing the foundation paper, there will be 1 mark that's reserved for you to do your calculation. Now, that's for kinetic energy. For gravitational potential, that is the energy that's stored in elevated objects and is represented by GPE. And the formula for calculating that is mass times, yeah, so that the M there is your mass, definitely, and the gravitational field strength, which is actually newtons per kilogram. Now that will be given to you as newtons per kilogram. Mass will just be in grams, and the H there is actually the change in height in meters. I have a typical question here which says a book with a mass of 0.25 kilogram. Let's watch this question. Is lifted 2 meters. Is lifted 2 meters, right, onto a bookshelf. If G is 10 newtons per grams, right, 2 newtons per kilogram, how much gravitational potential does it gain? So this is very simple. You do all of that calculation and you're going to end up with 5 joules. All right. Remember, you allow the calculator, so use your calculator. Another question says, why you say, why is theoretical velocity not normally reached? Well, theoretical velocity is just the velocity that's possible, the highest form of velocity that's possible. Hi, King of Games, how are you? Thanks for joining in. It says the theoretical maximum velocity is the total velocity possible, but the actual one is the one that you will be asked to calculate. If you're asked to calculate the theoretical one, you'll be given the answer, but nobody would actually ask you to differentiate between the two. As it is there as a checklist, I just put it there. All right, question 12. By the way, I have all of these and I'm going to upload it today. Okay. For the question 12, it says you should be able to manipulate the equation with specific heat capacity. I don't know how many of you I remember your specific heat capacity, and I don't know if you can see my board clearly. The calculations need to show very well. How many of you remember how to calculate specific heat capacity, right? Your specific heat capacity calculations, you should be able to do that, all right? I'm going to look at an example. It says specific heat capacity of a substance is the amount of energy needed to change the temperature of 1 kilogram of the substance by 1 degree Celsius. So different substances have different specific heat capacity, and a table is given. This table is given, all right? This table is given. Yes, someone has given me the, yes, fantastic. Josiah, yeah, well done. That is it. That is it. That is the specific heat capacity. I've got it here. I've got a specific question. It says here, it says if how much energy must be transferred to raise the temperature. Let me write it. It says how much, let me put the question here. How much energy, yeah, must be transferred, okay, how much energy must be transferred to raise the temperature, of 2 kg of water from 20 degrees Celsius to 30 degrees Celsius. I just want to quickly point out to you that the first mark for this question will be the calculation here, because 30 take away 20 is 10 degrees Celsius. That will give you your first 1 mark. See, before you even use the formula at all, then your formula is then going to be E is equal to your what? M times your C times your change in temperature. Theta is used to explain the change in temperature. So for this particular question, the mass is 2 grams. We multiply that by the specific heat capacity of water, which you will be given, and is 4180 in this particular instance is given as, yeah, and then you multiply it by the change in temperature, which is 10 degrees Celsius. If you calculate that out, you're going to get a total of 83,000. Hang on, I need to lift it up. I need to write the answer. No, I'm fine. I'll just rub this off. And so the answer there, watch this, is 83,000 620, and that is in joules. But the question was given in kilojoules. Please, is anybody watching able to just quickly convert this to kilojoules for us? The reason I'm doing that is because if you divide by 1,000, that's right. Well done. Someone's following. Divide by 1,000, so it's going to be 83.620. Now, what if they ask you to reduce that to just two significant figures? Easy. Well done. This is easy. You're gonna be great. Don't worry. You're gonna be just fine. All right. Yeah. This is just a reminder. Yeah. Well done. That's it. Well done. Okay. Yeah. All right. Very good. Excellent. Okay. Well done. Well done, Adam. You're on track. And Josiah, you're on track as well. Okay. I've got a few more questions to go over with us. It says what is a closed system? Yeah, you remember closed system, you need to go over that. What's a closed system? Okay, you said they may not provide. If you're doing the higher one, you need to know it. If they don't provide it, you just use that rounded off one. All right, well done. So it says yeah, are you okay? Have you revised your closed system? In a closed system, there is no additional energy being added or removed. So, like in chemistry, when we did an equilibrium state where the forward reaction is equal to the backward reaction, yeah, in a closed system, there is no additional where energy added, there is no loss either. I'll give two quick examples. If, for instance, you're cooking with your pot, yeah, and it's open, and there is transfer of energy from your gas cooker into the water is boiling. If the water is boiling, there is loss of energy. It is not a closed system, all right? But however, if you have a thermos flask, right? If you have your thermos flask, for example, that is a closed system because the surfaces, they reflect back the heat into the substance, and that is a closed system, so the temperature is maintained fairly. Yes, it's got something to do with conduction and insulation. It's also got a lot to do with conduction and conduction. Yeah, the polystyrene cup is a way to keep it in. Remember though, if it's in an experiment, you must say that for the polystyrene cup, you must put a lid over it so that you can improve the method, so that you can get maximum result or best result possible. If a polystyrene cup correct, it will not have a weight loss of energy, loss of heat, but you must put a lid if you're asked to improve the method. Now, I want to just quickly look at the next question that I have here. I say the factors that affect thermal conductivity in a building. So if you have a building, right, what are the things that need to be in place, right, so that it can stop the loss of heat in a building? Now, this is closely related to things like payback time. If you remember, yes, insulation, fantastic. And the method of insulation is, if you have a building, yeah, you can have loft insulation. The others can be double glazing. Yeah, you can have double glazing, and then you can have cavity, yeah, wall cavity, you feel, yeah, wall cavity. Yeah, you can have all of these methods of keeping, yeah, all right. Well done, Adam. Excellent, you beat me to it. Now, it can be asked as a 6 marks question. If it's asked as a 6 mark question, though, they will need to give you some information. For instance, they will give you information about how much this one costs and how much that costs and how much that one costs. So what I'm talking about is payback time. So the payback time, right? The payback time is how long it takes for you to recover that money in terms of the savings you have on your electricity bills and all of that. So if every year you save a total of, say, £2,000 a year, which is huge, all right, and then your initial amount that you invested was £20,000, that means it's going to take you a total of 10 years to how much is that? If you paid, if 2,000, oh, that's really short. So that's really, really short. If your initial investment was 20,000 and you save, let's say 200 each month, let's use something more. Yeah, if you divide, cancel that out, this two with that, that's okay. My first calculation was better. So 20,000 divided by 2,000, right? So what you have left is 10. Yes, 10 years. So it's going to take you 10 years. So in that 10 years to pay back, right? Sorry about that. There's a problem with my connection again, sir. It's going to take you 10 years to pay back. But if you have something that's much more, that takes longer, right, for you to pay back, right, then that is not a good investment. So when you're given such a question, please remember to look at all the information that you are given so that you can use it to compare it. So I also did a quick reminder. For those of you that are doing foundation, this is handy. I did a quick reminder for you to remember all of these. Yes, that will be for 6 marks. Trust me, because it's something that has got to do with everyday living. Because in physics, you don't really have too many of such examples. So 6 mark question would be something like related to that, because it's everyday decisions that people have to make, and people are encouraged. And another one is the solar panels as well. Yeah, they can include the solar panel as well. And then something just popped up in my head. It might just be a 1 marker. The three wires in a socket. Yeah, the live wire, the earth wire. The live wire is the brown one. How you remember, it's like the color of copper. Yeah, it's like the color of yeah. You have to find out if it's cost effective or not. Well done. Okay, the live wire is the brown one, like the color of copper. Obviously allows electricity to pass through. The green one, we are all going green in the earth, so that is the earth wire. You're only left with the blue, and that is the neutral. Okay, I want you to take a quick look at this. It's just a quick reminder, circuit basics. So yeah, you have the cell or the batteries here, the switch open, switch close, ammeter, voltmeter, the motor, the resistor, the thermostator, the fuse, the diode, right? Remember? And then I hope that was not too fast, because they are really basic. So I'm not actually good analogy. Thank you. I'm not really, I'm not really living it. So these ones, right? L These are the light emit, the LED, yeah, and this one is the light dependent resistor. And then this is the filament or the bulb, easy for everybody. Variable resistor, the DC supply and the AC supply. A quick reminder for a 1 marker, yeah, direct current comes from, yes, like from your battery. And oh, it's not very clear, sorry. Oh, I don't know, maybe the green color, but that's light bulb, that's variable resistor, and that's your DC supply. And alternating current can flow from either side, all right? Okay, and then another thing I want to quickly just remind you is your current, how to calculate your current, okay? Your current is V is equal to I times R. This is your resistance, right? These are just very, very simple things to remember. That is the current, and that is the voltage or potential difference. All right. Remember that's a very handy formula to quickly remember and use in exam. Some people say, oh, they can't remember lots of them, but this is really easy for you to remember this one. Okay, so that's very handy to hold on to. All right, now you also have the one that's Q equals to I times time, right? This is current, this is time, and this is the charge flow or the flow of charge. If they want to tell you how much charge passes through and the current is given, the time is given, you can calculate. Yeah, it's better to record. Oh, it's lagging loads. I'm so sorry. Okay, then what I'll do for the next video, I'll record it tonight or tomorrow morning, and then I'll post it. Is that all right? Is that all right? I will post, I'll record, and then I'll upload. Okay? I don't know. Sometimes these internets, I think it's the trees around the area where we live. We have so many trees, and they just block off your internet connection. But when I'm watching a video or when I'm doing something online, it doesn't actually fluctuate. Why is there a problem with my live show? I just want to do live because it's easy. People can ask me questions, and if there's any mistake, people can correct it. Because I know you are very smart. You know, you're smart, you're going to do well in this test. Don't worry. In this exam, it's not a test, it's an exam. Okay, then. I remembered something before I forget it. What was it I remembered again? I wanted to remind you quickly of your voltmeter and your ammeter connection. Yeah, please don't forget that. That is so easy. You want to be able to connect correctly. So do your two lines. This is your voltmeter. It's connected in parallel, right? Remember, and your ammeter is connected in series. And that reminds us, that should help us to recall our parallel circuits. And so 1, 2, this is 1 for that. And that's your voltmeter for this one. Yeah, very simple things to remember. Okay, so what I'm going to do, since it's fluctuating so much, I will do a recording, and then I will come back and go over. So I will record some other ones, and then I'll upload them. Okay, the exam is on Thursday, so I still have tomorrow morning to do this. I will upload the video, and then you can actually have it to hand. But the questions that I've put together, I'll share it and put the link here so you can actually download the questions and use it for your practice. I just wanted to do a quick half an hour because I know I couldn't start on time because I had something that I was doing earlier. Okay, yeah, Grapples only, you're more than welcome. In any way that I can help, I will. I didn't do these things because I was not really feeling too well. I'm usually a very healthy person. I'm never ill. I've got very good health. But what happened? My alarm again has gone off. But what happened was on Friday, on Thursday and Friday last week, I had a bit of a you know, tummy ache, and I don't know if it was something I ate. It wasn't food poisoning. I just don't know. We kind of did a little bit of funny stuff with my system, and then I was always feeling sick. On Friday, I actually got to a point where my student said, Miss, you need to go home. You don't look well at all. You know, usually when I'm teaching, I don't sit down, but I saw myself wanting to sit down. I was just tired. I don't know if I was exhausted. I went to the doctors. Funny enough, there was nothing. The lady said to me, "Oh, you're as fit as a fiddle." My my blood pressure was just amazing. Everything was okay. I'd even she showed that she saw that on my medical records I've lost a few pounds because I've been on this weight loss challenge. She told me, "Oh, well, you've lost a few pounds," and everything was good. Temperature was fine. So she just said to me, "You know what? Go home and chill. Drink a lot of fluids." So that was the reason why I couldn't do this video over the weekend. I wanted to, but don't worry, I've done a few questions today. Quick reminder, I'll do some other things. I don't see if anybody asked any particular question other than the triple and all that. So my major focus is to support people doing the combined and especially the foundation to help them to get those marks that they did not think possible. Keep keeping positive whatever you do and keep revising because you can. God bless you.